Hello friends, welcome to Shiksharthi. In this session, we shall be discussing the combination of functions, and under the head of combination of functions, we'll be using domain and range as a major tool. So let's start. Now when we say combination of functions, let us first try and understand what do we intend to say by combination of functions. So let us say if there is a function fx that I have taken, which is formed with the help of two or more functions. Incidentally, we are taking only two functions here, and as I said, that combination of functions is when you take two or more functions and you combine them with the help of mathematical operators. And here, as of now, I am only talking about the basic mathematical operators, though we can use other mathematical operators as well. And if we do the same for three or more functions as well, it is then we say that two or more functions combined together with the help of various mathematical operators give rise to an ultimate function, which is fx in this case. Now, the second question that arises after this is, what is the kind of combination that I can take? For example, what is the basic combination that I can take here? So let us say I take two combinations as 1 multiplied with 1 by x, right? Or I could have taken a combination as x into 1 by x, or I could have taken a combination as 1 plus x into 1 by x, or I could have taken a combination as 1 plus x square into square root of x. Or let us say finally I could have taken a combination of 1 plus x plus 1 by x. You can take any kind of a combination here when it comes to two or more functions with the help of basic mathematical operators in between. You can talk about other mathematical operators also. It is nowhere given that when it comes to combining the functions, you are supposed to take basic mathematical operators only. You can take exponential functions, you can take logarithmic functions, you can take greatest integer functions, you can take least integer functions, you can take a Dirichlet function, you can take any combination, any operator. Okay, this is one aspect of it. The other is, now once we know that, we are already aware of the fact that the domain is a launch pad to a function. Now when we say that the domain is a launch pad to a function, then a combination of functions giving rise to an ultimate function fx, what will be the domain of that function? So the domain of this function fx will be nothing but the domain of the individual functions which were responsible in getting combined with each other with the help of various mathematical operators. You take their domains, individual domains, and then you take the intersection of that gives rise to the domain of the ultimate function, that is fx. Okay, now what we are gonna do here is we will use the theory that we have discussed here to find the domain and the range of any two examples that we have discussed here. So one example that I'm going to take forward from here is, so let's say that I'm taking a function that is formed with the help of 1 plus x into 1 by x. I will not write this as 2. Why I will not write this as 2? Because when you write this as 2, what you are trying to indicate is the range of the function, and Range is the destination point of the function. Before you reach the destination, you have to talk about the domain, the launch pad. So now let me use this and let me try and understand that whatever we are discussing here, how do we take it to its logical conclusion. So if I'm specifying the domain of fx now, so let's say the domain of fx will be the domain of 1. What is the domain of 1? X belongs to real numbers. Let's put this in a parenthesis, let's say curly bracket, intersection with the domain of x. What is the domain of x? Real numbers. Intersection with domain of 1 by x. And what is the domain of 1 by x? X is less than 0. Union with x is greater than 0. Then you take the intersection, and once you would have taken the intersection, you would say that the domain of fx is nothing but x less than 0 union with x is greater than 0. So this is nothing but the domain of the function fx. And once you have specified the domain of the function, it is then only thereafter you are going to talk about the range of the function. I repeat, after the domain of the function is specified, it is thereafter or then only you talk about performing any mathematical operation on the function, which is you want to cancel the numerator or the denominator by a common factor, etc., is a kind of an operation only. So any kind of an operation will be done on the function after you have specified the domain of that function. So which now you will say that fx is equal to 2, which is nothing but the range of the function. So what is the domain and what is the range? The domain is x belongs to real numbers except for 0, and the range of this function is 2. So it is a constant range. So can you draw this function? Yeah. So the next question which arises here is, can I draw this? Of course I can. And while I am drawing this, I know that this is a constant function which is not defined for x is equal to 0, and this is the graph of the function. Okay, let me take another example here, which is gx, and here the other example that I am taking here is 1 plus x plus 1 by x. So as discussed earlier, can we find out the domain of gx? Yes, the domain of gx will be domain of 1, domain of x, and domain of 1 by x intersected with each other, which will give you that x is less than 0 and at the same time x is greater than 0. Okay, talking about the range of gx now. So the range of gx, for that you'll have to take up values, and once you start taking the values as we had done in our earlier sessions, you will see that the range of this function will be minus infinity to minus 1 union. Okay, let me see whether I can include minus 1 or not. So can we say that the range of gx is nothing but minus infinity to minus 1, where minus 1 is included, union plus 2 to plus infinity, where 2 is included. So maybe instead of a 2, if I were to just correct this to a 3. So how will you check this? You will check this with the help of the basics that we have already talked about in our earlier sessions, wherein you just have to put the values. You know that you cannot put any value like x is equal to 0, but you can put any negative value. So when we are putting negative values here, we can take this as a separate entity and we can take this as a separate entity. Now this here refers to a constant function x, 1 and x plus 1 by x. So you will see that the minimum value of x plus 1 by x for x being negative, when you take x negative, what is the maximum value that you can get is minus 2, and the minimum value that you can get here is minus infinity. When added to a 1, you will say minus infinity to minus 1. What is the minimum value of x plus 1 by x is what you can get when x is positive is 2, and when you add 1 to it is 3. And what is the maximum value that you can get for x plus 1 by x when x is greater than 0? That is plus infinity. I hope you will be able to understand this and take your learnings to the next level. And unless and until the learnings are joined with each other as links in a chain and made progressive, you cannot take your learnings to the next level, which is why it is suggested that whenever you do some session, please ensure that is this the first session or there are some couple of sessions which have already taken place which need to be done earlier before you come down to this session, and then take your learnings to the next level.